Good morning. Today our new class is Hartley oscillator. Today our new class is Hartley oscillator. Okay. Next, recap of this presentation. In previous class we discussed about requisites of an oscillator or requirements of an oscillator and basic oscillator feedback circuit and basic oscillator feedback circuit. These two topics are completed in previous class. And next, objectives of this presentation: on completion of this period you would be able to understand what is Hartley oscillator or working principle of Hartley oscillator and summary. Okay, so first of all, Hartley oscillator. So figure shows the circuit of Hartley oscillator. Figure shows the circuit of Hartley oscillator. See this figure. This is the figure of Hartley oscillator circuit diagram. This is the Hartley oscillator circuit diagram. So in this circuit diagram, observe this. Its tank circuit. Observe this tank circuit. Its tank circuit consists of two inductors L1 and L2. So and one capacitor C. So two inductors. These inductors are connected in series, L1 and L2. Two inductors are connected in series and a capacitor is connected across them in parallel. And a capacitor is connected across them in parallel. The coil, inductive coil, inductance coil. The coils L1 and L2. First of all, the coil L1 is inductively coupled to coil L2. The coil L1 is inductively coupled to coil L2. So and the combination works as an auto transformer and the combination works as an auto transformer. I repeat once again this point. So this is the circuit diagram of Hartley oscillator. So in this Hartley oscillator circuit diagram, tank circuit. See this tank circuit, it consists of two inductors L1 and L2 and one capacitor. So two inductors are connected in series and capacitor is connected across them in parallel. The coil L1 is inductively coupled to coil L2. The coil L1 is inductively coupled to coil L2 and the combination works as an auto transformer. In this Hartley oscillator, so this is widely used as local oscillator in radio receivers. This Hartley oscillator is widely used in local oscillator in radio receivers. So this Hartley oscillator circuit is similar to Colpitz's oscillator circuit. This Hartley oscillator circuit is similar to Colpitz's oscillator circuit except that feedback network consists of two inductors L1 and L2 and a capacitor C instead of two capacitors C1 and C2 and one inductor L in Colpitz's oscillator. Okay. Next. So in this circuit diagram, observe the circuit diagram R1 and R2. R1, R2 forms a potential divider bias. It is nothing but self bias. R1, R2 forms a potential divider bias. So and again next RE. RE is nothing but emitter resistor. RE is nothing but emitter resistor. What is the purpose of RE? What is the working principle of RE? So RE provides thermal stability for the transistor. So RE provides thermal stability for the transistor. So and next CC. CC means input CC and output CC. Any one CC. CC means coupling capacitor. What is the purpose of coupling capacitor? What is the use of coupling capacitor? Coupling capacitor is used to blocks the DC signal and allows AC signal. Coupling capacitor is nothing but CC, to blocks the DC signal and allows AC signal. So that is the working of or use of coupling capacitor CC. And next CE. CE is nothing but emitter bypass capacitor. CE is nothing but emitter bypass capacitor. What is the working principle or what is the use or what is the function of CE? So it is CE is bypass capacitor. It is used to pass the amplifier. CE is used to bypass the amplified oscillations. CE is used to bypass the amplified oscillations. If CE is not there, if CE is not connected parallel to RE, if CE is not there, the amplified AC oscillations, will drop across RE. The amplified AC oscillations will drop across RE. So then the gain is reduced. That's why CE is connected with parallel RE. Okay. So next in the circuit, so then next one is RFC. RFC means radio frequency choke. RFC means radio frequency choke. So radio frequency choke is permits unflow of DC current. Radio frequency choke, RFC is radio frequency choke. It is permits a flow of DC current. And blocks AC current. Because of AC signal on the power lines to affecting the output signal. Because of AC signal on the power lines to affecting the output signal. I repeat once again the functioning of RFC. RFC means it is nothing but radio frequency choke. RFC is radio frequency choke. What is the purpose of RFC? So RFC permits and flow of DC current but blocks AC current because of AC signal on the power lines. To affecting the output signal. Okay. So these are the different components and working principle or functioning of Hartley oscillator circuit diagram. Okay. So next, this is the construction of Hartley oscillator circuit diagram. And next, what is the working principle or circuit operation of Hartley oscillator? So see this. When the power supply is switched on, power supply is nothing but plus VCC. When the power supply is switched on, transistor starts conducting. The transistor starts conducting and collector current increases. So when the power supply is switched on, the transistor starts conducting and collector current increases. As a result, the capacitor C1 starts charging, and when the capacitor is fully charged, it starts discharging through coil L1. The charging and discharging creates a undamped oscillations in the tank circuit. I repeat this point again. When the power supply is switched on, the transistor starts conducting and collector current increases. As a result, the capacitor C starts charging, and when the capacitor C is fully charged, it starts discharging through coil L1. This charging and discharging creates undamped oscillations in the tank circuit. So what is the purpose of tank circuit? Tank circuit produces 180 degrees phase shift. That goes to output, and also transistor CE amplifier itself produces another 180 degrees that goes to output. Okay, thus a total phase shift of 360 degrees. And hence the feedback is positive. Which is an essential condition for developing sustained oscillations. Okay, so I repeat once again. So this point here, observe this. So first of all, when power supply is switched on, the transistor starts conducting and the collector current increases. So as a result, the capacitor C1 starts charging, and when the capacitor C is fully charged, it starts discharging through coil L1. This charging and discharging creates a undamped oscillations in the tank circuit. This charging and discharging creates a undamped oscillations in the tank circuit. So this tank circuit produces 180 degrees phase shift, and also transistor CE amplifier itself also produces another 180 degrees phase shift. This tank circuit phase shift 180 degrees goes to output, and another transistor CE amplifier itself produces 180 degrees phase shift also goes to output. Thus, a total phase shift of 180 plus 180, a total phase shift of 360 degrees, and hence feedback is positive, and hence feedback is positive, which is an essential condition for developing sustained oscillations. Okay, which is essential condition for developing sustained oscillations. Next, the frequency of oscillations is determined by the values of the frequency of oscillations is determined by the values of L1, L2 and C is given by F is equal 1 by 2 pi root LC. F is equal 1 by 2 pi into root LC hertz. I repeat this formula again. The frequency of oscillations is determined. The frequency of oscillations is determined by the values of L1, L2 and C, and is given by F is equal 1 by 2 pi root LC hertz, where L is equal L1 plus L2 plus 2m, where L is equal L1 plus L2 plus 2m. Here L1 and L2 are connected in series. So where M is nothing but mutual inductance between L1 and L2. Okay. Next, observe this. The output of amplifier is applied. Output of amplifier is nothing but V out. So see this figure. This is the figure of feedback circuit. Observe this feedback circuit. The output of amplifier is applied across inductor L1. The output of amplifier is applied across inductor L1, and the voltage across inductor L2 forms the feedback voltage. So here the coil L1. So L1 is applied to output voltage, and the coil L2 is applied to feedback voltage VF. The coil L1 is inductively coupled to coil L2. The coil L1 is inductively coupled to coil L2. So the voltage across L2. The voltage across L2 is actually fed back to the base of the transistor. The voltage across L2. The voltage across L2 VF is actually fed back to the base of transistor. The feedback fraction or feedback ratio. So is denoted by beta. What is the definition of beta? It is defined as the ratio of feedback voltage to the output voltage. Actually, beta is the ratio of output voltage to the input voltage. Feedback fraction is defined as the ratio of output voltage to the input voltage. Here, see this feedback circuit. Here, output voltage is nothing but VF and input voltage is nothing but V out. Substitute output voltage VF and input voltage V out in feedback fraction equation. Therefore, beta is equal VF by V out. That is equal VF is applied to inductance coil L2. So inductive reactance XL2 by, so V out is applied to inductance coil L1. So that means inductive reactance coil L1. So that is equal beta is equal XL2 by XL1. Beta is equal XL2 by XL1. So XL is nothing but omega L. Similarly, so that implies substitute XL in terms of omega L. So that is equal omega L2 by omega L1. So omega numerator and denominator same value is required. That's why omega is gets cancelled. Then beta is equal L2 by L1. Then beta is equal L2 by L1. Okay. So this is the feedback fraction in Hartley oscillator. Okay, so feedback fraction Hartley oscillator beta is equal L2 by L1. Okay, next, the minimum value of amplifier gain to maintain oscillation. The minimum value of amplifier gain, the minimum value of amplifier gain to maintain oscillation is A beta is equal 1. The minimum value of amplifier gain to maintain oscillation is A beta is equal 1. So that implies the gain, amplifier gain A is equal 1 by beta. We know the formula for beta is equal L2 by L1. Substitute beta is equal L2 by L1 in this gain equation. Therefore, gain A is equal, so 1 by L2 by L1. Okay, that implies after simplification of this, the amplifier gain, the minimum value of amplifier gain is equal L1 by L2. Amplifier gain A is equal L1 by L2. Okay, so this is nothing but operation or working principle of Hartley oscillator. Okay, feedback fraction and amplifier gain also find out. Okay, next, summary of this presentation. We have seen Hartley oscillator. And next, frequently asked questions may be asked. And next, frequently asked questions may be asked in today's topic. The first question is, explain the working of Hartley oscillator. So in today's topic, so the another question may also be asked, define feedback fraction and amplifier gain. Write the formula for feedback fraction and amplifier gain in Hartley oscillator. Okay, so next question may be asked, draw the circuit diagram of Hartley oscillator. Okay, so these questions are may be asked in today topics. So today topic is very important topic, Hartley oscillator. If it is Hartley oscillator is understand, then also easy to understand Colpitz's oscillator. Only change of inductor in terms of capacitor, and a capacitor in terms of inductor. Okay, so observe this once again. So these are the Hartley oscillator. So this is a circuit diagram. So construction of circuit diagram and operation of circuit diagram and resonant frequency. So in this frequency of oscillations formula by using problems. Okay, so then problems are given to solve this formula also of Hartley oscillator. Okay, so this topic is very important topic. Okay, all of you, thank you.